Molar mass problems. That's easy.
Yeah, you just look at the periodic table.
Exactly. Grams divided by moles is molar mass, right?
Well, yeah, but you just periodic table and you add them up.
Yeah, exactly.
Really?
Well, yeah, if we know the formula.
Yeah, guys, the key on this reaction, or this podcast, is that we're going to take the grams and we're going to divide by the moles. Take the grams and divide by the moles. What are you going to do?
Grams
divided by moles. We have to find the grams one way and the moles a different.
Right.
So before we've done this, what we've done is we've taken, added up, like, if you got H2O, you'd say, well, there's 2 plus 16, and you got 18 grams per mole. Mm-hmm. But you know what? We're going to try to find this answer via an experiment.
Right, and we don't know the formula of the compound.
And
That's what also we're trying to find.
We don't know this. So how could we find this number without knowing this? Well, we know you take grams and you divide by moles.
Right.
So X grams divided by Y moles, and you get the answer.
Yeah.
Okay, so let's see if we can figure out how we can do this experimentally. All right, here's well, there it is.
Hey, grams divided by moles is molar mass.
Everybody write this down, but hopefully you know that.
Yeah.
This will help you identify the identity of a chemical.
Right, you guys are going to do a little project if you're in our class where you have to identify a substance by its molar mass. You're going to have to do this, like in a lab.
Yeah, so once you know the grams and the moles, you divide.
Yep.
And that gives you, just a side note, when you take a grams divided by moles, that tells you how many grams in 1 mole.
Right.
Maybe an analogy would be, let's say that you go 82 miles in 2 hours.
Yeah.
Okay? If I wanted to know how fast I was going,
41 miles an hour.
You would divide 82 by 2, you would get 41 miles in 1 hour. Now, you didn't travel 41 miles, you traveled 82, but in 1 hour, your speed was, your average speed was 41 miles per 1 hour. So if you know the grams, X grams divided by Y moles, then you can get the grams per 1 mole.
Yeah.
Okay?
Okay.
All right, let's do an example.
See
okay.
what happens.
Oh, actually, here is the rules. So you should go and pause the video.
Yep.
And then write these down. Okay. All right. So let's pause. All right. We're back.
Okay.
All right. So let's do the example. All right. We do not have a balanced equation.
No, we should probably get one.
Okay. 22 or 2.23 grams. All right. I'm going to ignore the numbers. I'm going to look at the chemicals first. Lead 2 chloride is formed.
Okay. That
means it's product. It's on the right side. When a metal chloride reacts with lead nitrate. Okay, I'm good with that. Right. So the metal chloride, so that's going to be, now the metal chloride, it tells me
we
that
don't
the metal,
know what the metal is.
So why don't we call it M?
All right.
But M has a charge of +3.
Okay.
And he's going to be a chloride, so I'm going to say Cl-1.
Okay.
Because chloride is in column 17 on the periodic table.
Okay.
So that'll be
MCl3. And we don't know what M is. That's what we're trying
Our goal is to figure out what is M. Reacts with
lead nitrate. Lead 2 nitrate.
Lead 2 nitrate. So lead is the symbol Pb, charges +2, and nitrate is NO3 -1. So that'll be Pb NO3 2, right? Because you got to get the council out, right?
Okay.
And no, it makes lead 2 chloride. Now that's going to be putting the lead, +2, with the chloride -1. When you put these together, you make PbCl2. Now the other product will be the metal nitrate. We know the charge of the metal is +3. This is a double replacement reaction, right? And the nitrate, so that's going to make MnO3 3. Now let's write a balanced equation. Okay. Who's most complex? I think.
Probably MnO3
Yeah, but we got an issue here, Mr. Sams. We got 2 here.
We got 2 and 3. Let's bring up 6.
Let's play the 6 game. So 2 here and 3 here. That gives me 2 metals. So I'll put a 2 over here. That'll give me 6 chlorides. So I'm going to put a 3 here.
And we have 3 leads.
And that's it.
There we go. Okay.
All right. Now, what do we know?
We know we have 2.23 grams of lead 2 chloride is formed.
2.23 grams of this. And we know we have
0.944 grams of the metal chloride. Now, guys, when you're doing these, I think it's easiest if you start with the thing you know everything about, and that would be the lead 2 chloride, because we know the mass of it and we know the identity of the substance. Do not start with your unknown metal thing. We're going to work towards the unknown metal thing.
Okay.
Right?
Now, one thing I want to also say, I think that's important. Molar mass is grams over moles.
Right. Hey, look, we have grams.
But we know the grams.
Yeah.
The grams is that's X grams over Y moles.
Right.
This is
0.944.
So we know we have 0.944 grams of MCl3 divided by Y moles of MCl3.
Which we don't know yet, but we can find.
We're going to find that,
stoichiometry.
and that will give us our answer.
Yes.
So what we're going to do is we're going to start with that 2 number. What was it? 2 point something. 2.23. So we're going to say 2.23 grams of lead 2 chloride. And now, an important thing here, guys, this is actually a shorter stoichiometric problem. We're just going to convert the grams of this to the moles of this. We're not going to go all the way to grams. Right. It's not a gram-gram problem. It's a gram-mole problem. Okay? So I'm going to say grams of PbCl3.
Do you know this one?
207 plus 71, or it's in the 300 range.
278.2.
Mole of PbCl3.
278.2.
278.2.
It's PbCl2, by the way, not 3.
Oh, that's where I was messed up. Okay, I said it should be higher than that.
All
Then
right.
I'm going to say the mole ratio. So moles of PbCl2 to moles of MCl, what was it? It's 3.
Yep.
And that's 1. And
No, it's not 1.
What is it?
3.
Yeah, this is a 3, and this is a 2. Okay. See, we have to go back and forth. This was a 3, yeah, and this is a 2. And then we're done. We do not do one more step.
Nope, right there.
So
that gives us...
usually small number.
Yeah, it's pretty small. It's 5.34 times 10 to the negative third.
Or 0.00534 moles.
That's moles. Right.
Of MCl3.
Right, so now we plug that
That's
in.
our Y number. So I'm going to take 0.944 grams divided by 0.00534 moles, and that'll give me the grams per 1 mole, which is 177
grams per mole, and that's of the MCl3.
Of MCl3. Now we're still not done, Mr.
No,
Sanders.
because that's the metal chloride. We want the identity of the metal.
So I'm going to recopy it here, and this is MCl3.
Right. So that's the total mass of that formula.
So
we need to subtract out the mass of the chlorine, and that'll leave us with the mass of the metal.
Chlorine, Mr. Sam, weighs 35.5.
It does.
And there are 3 of them, and that would add up to a little over 100.
106.5.
106.5 grams. So if this consists of some metal, M, plus 106.5, and that adds up to 177, well, we could subtract 106.5 from both sides.
And we get 70.5.
70.5 is the molar mass, grams in 1 mole of the metal. Now, I'm going to look on my periodic table. I wonder if we should just throw up a periodic table. I think we should look at the periodic table. Mr.
I think
Sams.
we should.
All right, so it weighs 70.5.
So we need to look for one that weighs 70.5.
Iron is 55. I see 63. I see 72. I see 16.
So it's in between gallium and germanium.
Oh, we got a problem, Sam. Nobody weighs 70.5, so we must have done our problem wrong.
No, my guess is that that's just some experimental error.
Yeah, that's true. There's experimental error. So here, guys, the key thing to understand here is we also know one other very important factoid. All right, at one point in the problem,
it tells us
that the charge of the metal is +3. So we sort of have 2 conditions. We know the charge is +3. If you remember our table here, right? Yeah. -1, -2, -3. Kind of a weird one here. +3, +2, +1. Hey, +3. So it's going to be the guys in this column. Well, the guy who's closest to 71, or 70.5, I guess, that's in here is gallium. So it is the element gallium. Yeah. So that was gallium.
It's closest in mass chloride. And fits the bill for the charge.
So yeah, experiments aren't perfect, right? So you can always, so you're close. Yours are, no, they're not. I thought you said you only had like 1% yield or 0.5%.
Yeah, that's right.
Yeah, okay. So
and
yeah,
I get pulled over for speeding.
And you got pulled over for speeding. So yeah, so that's close enough. So you're looking for something with the right charge, and you see gallium fits the bill.
Yeah.
So you're going to be doing quite a few of these problems, and you're going to do a project where you basically will do that. You'll actually have in the project, if you care, you might have, for example, cesium carbonate, and or some alkali metal carbonate. You get one of these guys to play around with, and you got to tell me which one it is. And so you have to kind of like subtract the carbonate and actually divide by 2 because the CS2, or Call it M2.
Yeah.
Okay, so that's how you do that. That actually concludes, right?
Unit 5, we're done.
The Unit 5 podcasts.
Woohoo!
That's
That's
like
it for this semester if you're our student.